Good morning, afternoon, or evening. How you all doing today? Welcome back to Mr. Morrow's geometry class. Today we are going to continue with our postulates to increase our vocabulary or our acumen on proofs and how to do proofs. And the only way to get better at proofs is to learn more and more information about proofs. So today we're going to talk about the addition and subtraction properties, okay? Consider the following segments, guys. We have JK is 3. We have KL is 8. We have LM is 3. In total, if you add them all together, JM would be 14. Now let's think about what we know here. Since we know that JK is congruent to LM, because remember, since JK is 3 and LM is 3, that means that their measures are equal. So if they're equal in measure, then we know that JK is congruent to LM. I put the two tick marks there because, as we know already, the tick marks represent that they are both congruent. Okay, so therefore, using algebraic addition property of equality, I can now say that JL is congruent to LM. Let's explain that part. If JL, if we look at JL in red here, wouldn't JL be 11? Guys? Okay. Now, look at yeah, it would be K. Thank you. Now look at KM. KM would also be 11, correct? So, that is called the addition postulate. And what the addition postulate states basically is the following. If a segment is added to two congruent segments, then the sums are congruent. The two congruent segments here are JK and LM. I added this KL piece to JL, giving me 11, and I also added the KL piece to KM, which gave me 11. So if a segment, which in this case, we're talking about segment KL, if a segment is added to two congruent segments, then the sums are congruent. Does that make sense, guys? Okay, I'll take that as a yes. I always like to put numbers into theorems when possible. For me, at least, when I put numbers into theorems, it just clicks a little bit better. It makes a lot more sense to me. Okay? Yes, sir, you have a question? Oh, okay, no worries. Okay, so what if I tell you AB is congruent to CD, as you see here in the figure to the right? What conclusion can I make? Yes, sir. AC will be congruent to CD. Okay? And also, AC will be congruent to BD. Okay? If AB is congruent to CD, then AC will be congruent to BD. Why? Because since I know that AB is congruent to CD, that was our given, if I add BC to AB and I add BC to CD, then I know that AC, all right, will be congruent to BD. Does that make sense, gentlemen? This is a very simple postulate, but at the same time a very powerful postulate. So again, if a segment is added to two congruent segments, then the sums are congruent. Does that make sense? All right, brothers. Let us continue then, if I may. The same is true for angles as well. The angle addition postulate, gentlemen, is if an angle is added to two congruent angles. Gosh, what is up with these typos? If an angle is added to two congruent angles, then the sums are congruent. For example, let's look at the angles that I have here to the right, below the definition. Given angle 1 is congruent to angle 2, you know me, I'm super label happy. So these two guys are congruent. What do you think I can conclude, being that I have that angle DBE in the middle? What do you think I can conclude from this if I tell you that angle 1 is congruent to angle 2? Yes, sir, my brother. Angle ABD will be congruent to angle CBE. Absolutely. Why? Well, I know that ABE, or angle 1, is congruent to CBD, or angle 2. But if I add DBE to both angle 1 and 2, then that means that this angle will be congruent to this angle. Because I added this piece here, this angle, to both this angle and that angle. Think of it in terms of numbers. Let's say that angle 1 is 40 degrees and angle 2 is 40 degrees. Let's say that DBE is 30 degrees. Then angle ABD is going to be 70, and EBC is going to be 70 as well. Yes, sir, you had a question, my man.
Yeah, why wouldn't it be angle ABD is congruent to angle DBC? Telling you that angle 1 and 2 already.
Angle 1 and 2 are congruent. That is angle ABE and CBD. That's a given. You just be substituting there. You wouldn't really be concluding anything. You would just be renaming those angles. Does everyone see what I just did there, guys? You sure? All right. Yeah? Go ahead.
So we come up with the conclusion angle ABD is congruent to CBD. Would the reason be, would we be able to put...
Angle addition property. Angle addition property, straight up. Yes, sir. Thank you, my brother. Now, using the above logic here, guys, one can conclude the following. If congruent segments or angles are added to other congruent segments or angles, the sums are also congruent. Let me give you two examples with both segments and angles. If you look at the trapezoid down here, trapezoid FDCA, you have the following. I know that FE is congruent to BC. I know that DE is congruent to AB. Let's put some numbers, okay? Remember that numbers can sometimes really save your life here. Let's just say for giggles that FE is 5. Let's say for giggles that then BC has to be 5. Let's say that DE is 2, and let's say that AB is 2. Now, visually looking at this with numbers, what can I conclude here, my brothers? What can I conclude, guys? Yes, sir. F what? What can I conclude here? Yes, sir. Thank you, my brothers. Look, guys, think about it. What's 5 plus 2, guys? And what's 5 plus 2, guys? So FD will be congruent to AC. Why? Isn't FE congruent to BC? And isn't ED congruent to AB? If I add two congruent segments, okay, to other congruent segments, their sums must be congruent. Yes, sir. This would also be segment addition property. Yes, sir. Does that make sense, guys? Okay, let's look at the triangles that I have here to the right. I know that angle IGJ is congruent to angle IHJ. I also know that JGH is congruent to angle JHG. What do you all think we could conclude from this? Yes, sir. I couldn't have said it better myself. Angle IGH, which is the sum of IGJ and JGH, is congruent to Wait, where am I getting this T from? What is that? This is an I. IHG, which is the sum of IHJ and JHG. So since this guy and this guy are congruent, and this guy and this guy are congruent, their sums must be congruent. Does that make sense? Promise? All right, boys. May we continue, gentlemen? Are you sure? Okay, thank you. What's up, my man? Why is H the vertex? Let's think about this. Okay, look at my figure up here. Look at my figure up here. I told you that this guy is congruent to this guy, and this guy is congruent to this guy. So isn't this angle right here I, G, J? Isn't this angle here I, H, J? Okay. Isn't this angle here J, G, H? And isn't this angle here J, H, G? So then in total, I'll do this in red now, isn't this sum here I, G, H? And isn't this sum over here, I'll do it in blue, I, H, G? Thank you so much for your honesty, my brother. Any other questions, comments, concerns on this, guys? May I continue? Okay, thank you, gentlemen. Let's do it. All right, subtraction property, similar to the addition property. Subtraction property. If a segment or angle is subtracted from congruent segments or angles, the differences are congruent. Again, look at the segments that I gave you, and look at the numbers that we have here. If I tell you that RS is 3, and I tell you that RT is 10, and I tell you that QS is 10, what do you know about QR? It's 7, thank you. What do you know about ST? It's 7. So didn't I have RT congruent to QS? Right? You see that, right? Because it's 10 and 10, right, guys? If I took away 3 from both congruent segments, well, 10 minus 3 is 7, 10 minus 3 is 7. That has to mean that QR will be equal to ST. Let's explain it in words. Let me erase this here, or actually, let me just go back. Okay. Since QS is congruent to RT, so this guy here, QS, is congruent to RT, okay, because they're equal. Therefore, if we subtract RS from both segments, then QR will be 7, like we just talked about. ST will be 7, like we just talked about, which means that QR must be congruent to ST. You had a question, my brother? Does that make sense, guys? Again, this seems very simplistic, very logical. It is, but you got to be able to extrapolate the information. Okay, you got to be able to understand it. May I continue? Yeah. Okay, same thing happens for angles. Okay, that's why the subtraction property, I shortened it and I said for segments and angles. In this particular case, guys, I'm telling you that angle ABD, which has the red, is congruent to EBC. Okay? But if you look at the angle in the middle, which is this guy right here, and I subtract that angle from both congruent angles, what are you going to know about angle ABE and EBC? I'm sorry, ABE and CBD, sorry. What are you going to know about that? They're congruent. Okay, why? Since ABD, which was the angle that I marked in red, is congruent to EBC, which is the angle that I marked in blue. Okay, since we know that. If we subtract EBD, which is the angle that I marked in green, from both angles, then what has to be equal? ABE and DBC. Let's put some numbers just in case you don't get it. Let's say, for example, that ABD in red is, I don't know, let's say it's 100 degrees. Then that means that EBC, which is in blue, is also 100 degrees. Let's just say, for argument's sake, that my green EBD here is 40 degrees. What's 100 minus 40, guys? So that means that ABE is 60. What's 100 minus 40, guys? So that means that DBC is also 60, and that means that ABE is congruent to DBC. Does that make sense? Yes, sir. It made sense without the numbers? How does that, I mean, what's 100 minus 40? 60. 100 minus 40, 60. So those two are congruent. Okay? If the numbers are confusing you, then don't use the numbers. I'm just trying to help you guys in every way that I can. But thank you for your honesty, sir. Say, yes, sir. Well, I'm not going to get into semantics. Some people can see it without numbers. Some people, oh, you don't know how to see it without the numbers? But, okay, we'll try to explain it again. Thank you, sir. No, thank you for your honesty. You understand that my red angle is ABD, right?
Yes.
And you understand that my blue angle is EBC, correct? All right, my man. If I take away this middle part, EBD, I'm taking away the same value from two congruent angles. So doesn't that mean that this part has to be congruent to this part?
Oh, yes, I got this.
That make sense, my brother? Thank you so much for your honesty. Guys, this is what I want. This is the good stuff. This is how I help you. This is how you learn. Thank you so much. Any other questions so far before I move on? I appreciate your honesty greatly. Okay, using the above logic, one can conclude the following. If congruent segments or angles are subtracted from congruent segments or angles, the differences are congruent. So why don't we look at the two figures that I give you this time. And in this particular case, guys, what if I tell you the following? If FD is congruent to AC, so that means that FD, okay, is congruent to AC, okay? Then that means that FE is congruent to BC after ED and AB are subtracted from FD and AC. So again, if FD is congruent to AC, if I take away ED and AB, which are both congruent, will that not make FE congruent to BC? Does that make sense, guys? You promise? Okay. Same thing with the angles here, guys. Who can tell me what you can conclude from this? If I tell you that JGH is congruent to FHG, what do you think can happen here? Okay. Well, if I tell you that IGH is congruent to, again with the T, to IHG, then IGJ, which is this guy, will be congruent to IHJ, which is this guy. After I took away JGH and JHG. Does that make sense, guys? Yes, sir.
So this is just so you can tell where the
Well, if you use the tick marks, it helps your life a lot easier. If you guys don't use tick marks, you are going to really be confused in geometry. Okay? Let's think about this again, my brother. Thank you so much for your honesty, sir. If I tell you, well, you'll know, but if I tell you that IGH is congruent to IHG, if I take away, guys, JGH and JHG, which are congruent from the larger angles, would that not mean that IGJ is congruent to IHJ? Are you sure, my brother? You have the guts to ask? I want to have the guts to answer. Thank you, my brother. Sir, numbers on the first one. Okay, yes, sir. If FD is 10, that means that AC is also 10. If ED, for example, is 4, that means that AB is 4. What's 10 minus 4, brother? So that's 6. What's 10 minus 4, brother? 6. So that means BC will be congruent to FE. Does that make sense, my man? Thank you so much. And as far as the angles are concerned, if I tell you that the whole angle IGH is, I don't know, let's say 60, that means then that IHG is 60 because I'm telling you they're congruent. If I take away JGH, which let's say is 20, and I take away JHG as well, which is 20, won't I be left with 40 for this guy and 40 for this guy? Does that make sense, my brother? Thank you so very much, guys. We're good? All right, let's do some examples. Now, how to use the addition postulate and the subtraction properties. An addition property is used when the segments or angles in the conclusion are greater than those given in the given information. A subtraction property is used when the segments or angles in the conclusion are smaller than those in the given information. For example, they tell you that XW is congruent to YV. So you know me, why is that doing that? I'm going to label. So XW is congruent to YV. They tell you that WZ is congruent to VT. They want you to prove that XZ is congruent to YT. Well, my first part is going to be my given, that XW is congruent to YV, that's given. My next would be that WZ is congruent to VT, that's given. And then my last step would be XZ is congruent to YT. Why? Addition property. If congruent segments are added to congruent segments, then the sums are congruent. Does that make sense, my brothers? Are you sure, guys? Because this is the kind of stuff you're going to see in the homework. All right. How about this bad boy? If BAC, which is this guy, yes, sir. You can watch the video. If BAC is congruent to BCA, okay, and DAC is congruent to DCA, what can I conclude? Yes, sir. Phenomenal, my brother. Angle BAD is congruent to BCD. Very simple. Why? If I put the two givens together in this case, BAC is congruent to BCA and DAC is congruent to DCA, that's given. Why would BAD be congruent to BCD though? Guys? Very good. If congruent angles are subtracted from congruent angles, then the differences are congruent. That would be the subtraction property. Does that make sense, gentlemen? I need your honesty. Okay. And think about what we said. The given information, the angles were larger than the conclusion, wasn't it? So I had to subtract. If you look at the first one, the given information, the segments are smaller than what we're trying to prove, correct? So when the given information is smaller than what we're trying to prove, that's addition. When the given information is larger than what we're trying to prove, that is subtraction. Okay. Number 3. Angle 2 is congruent to angle 3. Angle 1 is congruent to angle 4. What can I conclude? Yes, sir. Phenomenal. XYV is congruent to ZYT. Why? Well, if I give my givens, angle 2 is congruent to angle 3, which I marked. Angle 1 is congruent to angle 4, which I marked. That's given. Yes, sir. ZYV. Yes, thank you. Good man. Thank you, sir. Yes, sir. Are you sure? Okay. No worries. No worries, brother. So I can conclude that XYV is congruent to ZYV. Why? Addition property. If congruent angles are added to congruent angles, then the sums are congruent. That's the addition property. Now, this is the best proof of the day. This is a good one. I love this proof. Excuse me. I have a trapezoid here. And I tell you that HEF is supplementary to EHG. Okay? So that means that this guy and this guy, they're not congruent, but they add up to be 180. We know that. And then they tell you that GFE and FGH are supplementary as well. So that means that equals 180. But then I tell you that EHF is congruent to FGE. And then I tell you that GHF is congruent to HGE. What do you think I'm trying to prove here? It's a hard one. You're going to try to prove that HEF is congruent to GFE. Let's run through it. Number 1, my given, of course. 2, my given. 3, my given. 4, my given. Now, here's where the A's are separated from the B's. If I know all of the following, okay, and I look at my figure, okay, you guys have the figure on your paper. Step 5 will be that EHG is congruent to FGH. Why? Because of angle addition postulate. If congruent angles are added to congruent angles, then the sums are congruent. And once I know that those two guys are congruent, I can now prove that HEF is congruent to GFE because supplements of congruent angles are congruent. Now, if I look at the figure here, what I figured out was that this guy is congruent to this guy because of angle addition postulate. Okay? But then I know that HEF and GFE are supplementary to those angles. So therefore, if angles are supplementary to congruent angles, then they are congruent, proving what I wanted to prove. Take a look at that proof at home tonight. Good luck on the homework. Thank you for a great class, and I hope you learned a lot. Have a great day, and take care, boys.